Oh, look at that. We are back online. All right, so I haven't streamed in a long time. I just finished the stream about me playing Dota 2. It's Herald 5 rank. We lost after 70 plus minutes. Not bad. But we had more kills. Anyway, it was a stupid loss. At that time of the game, you definitely lose game. Just one stupid mistake and exactly what we did. Anyway, so I was reviewing some of my old videos, like how I introduced myself, how I actually gave introduction to every video, hello everyone, how outro looked like, and outro was like, hey, stay safe, stay good. It was during some different times. We live in a way better times right now. And so yeah, it's the reflection. It was really nice. I haven't recorded anything in 2 years. I just realized there are many reasons why. In general, I was onto something with the team, building AI products. Also, AI, trying to build new AI architectures, all sorts of things. Also, training the models, fine-tuning the models. Building internal infrastructure, whole vertical, everything from the hardware to the to upgrading the firmware, to the right operating system choice, driver choice, even like fixing the hardware issue on the actual hardware, like removing parts so you can get more performance. It was ridiculous, and it's something I really like and I still do. So then there are engines, there are different kind of engines you run, and then on top of them you have different models, and on top of the models you have all sorts of like libraries, frameworks, things. We try to remove all of the clutter, all of the I can easily say like all bullshit, and just leave what's really needed, because people over the last 2 years, to maybe 2.5 years, built so much crap and crap on top of crap, and now we have the layers of abstractions which are not only leaky but are terrible, bad. The newcomers don't know what's happening. The big companies, there is so much money into all these frameworks. Everyone is saying, hey, our framework is better than yours, and so on. Try on. We try them, we play with them. Don't take everything for granted. Some of them are good, some parts are good, most of the parts are bad. That's my opinion, not only mine. You can see that people creating content are creating content so they can either promote this kind of libraries, frameworks, technologies, or they're just doing that to boost their own, visibility on the social media. This is kind of interesting. Like in 2008, I actually explained how I see how technology is going to look like one day, that we'll be able to write down what we need, explain to machine what we need in simple terms in our own languages, like you choose it, like English, German, Spanish, Italian, Chinese. It's really whatever you want to use, different dialects, and then explain what you need, and you'll get most of the time what you want. In 2020, 2021, there was a GPT-J, like there were transformers made a really big, like, big impact to the overall architecture of AI ML models. And then we were finally able to train these generative pre-trained models. And I remember clearly explaining this. It was 2020. And to one of my ex-coworkers, I'll explain, you know what, we're building this thing called Tangle Hub. It's a platform where developers will be able to easily build applications. They'll mostly care about the back end, not that much about the front end. We'll leave a lot of, the freedom for front-end developers to pick what they like. And we'll be very, very soon, we'll be able to explain to machine what kind of software we want to be able to do it. colleague looked at me like I was crazy. We were at some dam walking, watching at the water on one side, on the other side watching an abyss. It was really interesting. Year later, a huge breakthrough, a lot of open source at that time. I remember like we played with GPT-J even without the fine tuning, just with the prompts, like in context learning. So we explain, hey, here is a library, you haven't seen it. Here is a simple API. Here is example. Try to use it. Do that. It was in English. It was okay. So to them, it looked like black magic. Many people who saw that thought, hey, this is like, it's impossible. It's working. Like there is really no sense it's working, because they thought that prediction next word is just Monte Carlo thing. Or the statistics, just like what would be the next word or token. I don't think that's happening, and we're seeing that lately. Since then, November, I think 2020, we got like ChatGPT. After ChatGPT and OpenAI breakthrough, like that really opened the door, opened the minds of a lot of people, got inspired a lot of people, and we moved to the era where every possible software has AI shitification. So basically, AI is embedded everywhere, including this beautiful, necessary GitHub platform where we publish our open source projects. I mean, I don't use Copilot. I tried all of these tools. They actually make me slower. I'll explain. We'll come also to that part. And realized that we built two platforms, one called TangleLabs, which is like general platform for collaboration between the humans and agents. By the way, this is almost 2 years since that platform exists. You can upload the files. You don't have to think of RAG, like retrieval augmented generation. You can attach to the external sources of your information. You can chat to the humans. You can chat to the agents. You can have like this. You can have like reactive chats where you ask some agent something or user something, or you can have proactive where you basically let agents talk to each other, interact with the humans, and so on and so on, and then you get like responses that you expect to get sometimes. So that's TangleLabs. Another service that we build is called the Tangle OCR. It's actually it's fork from the TangleLabs technological fork. I'll leave it like that. So basically, what it does, it's generative AI OCR, like OCR 2.0, like magical OCR thing, on a completely different level. So imagine that you, instead of giving OCR to machine, you give OCR to 1 million people to do something, and then you can also ask them question, did you see any mistake? Can you correct the mistakes? Can you rewrite this document different style? Can you rewrite exactly word for word, character by character? Can you redraw like charts? Can you get data from charts? Like all the crazy stuff. And it's really nice. It's a really simple product, mostly interactive via API. But here is the interesting thing. Around 2 years ago, like that time, I realized something, that every time I need to go and ask front-end developer to develop something for me, to explain to UI UX designer expert, whatever you want to call them, what I want, I had to wait time for the UI, for the UX, for multiple iterations in a very competitive space where every minute counts. That was like very, very bad. Of course, you have design systems. You design them, you develop them. Depends on how you see them. Then you use them to build So instead of building just the wireframes, you just use design system to basically build, these prototypes. But they're prototypes how the software should look like. The problem still was then the front end had to develop that part. All right, so front end develops. Then we explore the backend if it was a perfect scenario, backend develops the API in the background, the backend team develops API in the background, and then we have to integrate this stuff. And then there is ML engineers, ML ops, DevOps. It was like it's really tough thing to do. And around that time, that was 2 years ago. Why I opened this? It's because I wanted to show you this. It was actually 2 years ago. So this project is created September 22nd, 2023. Actually, less than 2 years, but GitHub is rounding this to 2 years. So I realized, you know what? Actually, it's more like a year, something ago. So it's going to be insane if we have to wait instead of like getting something in a day to still wait a month for developers to finish something. These developers will lose job, and because we are going to lose the edge on the market and everyone else will be faster. And people really hated that idea. I understand why they hate it. It's completely fine. They think they're going to lose job. I don't think that's the case. I think people, when developers see these kind of tools, they can do more. But the goal is the following, so that we have one framework for the backend, for the frontend, that not framework, actually a library that will help us develop the backend logic, and also on the frontend implement all of the frontend logic, and if possibly be done in the same language, and that language is Python. So the goal was to have Python on the backend and the frontend, and then also remove all of the reactive crap that we have so far. Those people who were never developers, who never studied computer science, and don't get me wrong, like there are brilliant people there, that don't understand why reducers exist, that don't understand why functional programming exists, that don't understand what is declarative programming, like what's imperative programming, just like throwing the lines and lines and lines of code and just causing like the complete collapse of the industry. Now the AI is cleaning all of that market, and they're asking themselves why they're losing jobs. So this is a controversial topic, and I understand that. So, and that's how Gladius started. So the goal of Gladius is actually to be a unification of backend and the frontend, using the Python, allowing Python developers on backend to use any Python library they can find on their own Python index, and on frontend using Python, but using every package they can find, or as many as they can find. I'll explain that in details on the npm.js, so not the package manager index. All right, so let me first like explain what this thing is. I have to show you, like, this is really simple what it is. It's this. So you basically, this is a simplest application you can develop. So it's completely agnostic if you are using AIO, HTTP, or you're using the past API, or it's really up to you, or Flask or Django. I really don't care. Like, but thing is, there are some starter, some starter utility functions, how to set up and create the apps for all of these frameworks, so you don't have to waste time. So in this case, I use AIO HTTP. And then I said, you know what? Actually, I need 2 packages to use on the client side. So I need Pico CSS. I am not. So this is like really interesting thing that people don't realize. I am in every role and none of the roles. So I'm backend engineer, which is not backend engineer, front-end engineer, which is not front-end engineer, DevOps, which is not DevOps. It's hard to understand what I do. But basically, I pick problems. I don't pick technologies, and I don't pick sites. So if the problem is to fix the hardware, to solder some stuff, unsolder, like remove parts from the PCB, I'll do it. If the goal is to fix, the firmware, you see, it's a hacker mentality, like what I'm doing. So I like to play with things. and understand them very deeply. I like to know like first principles, why things work the way they work. So in this case, since I didn't want to play with any custom CSS written by hand, we will get to the part where we will need. I didn't want to use like Tailwind because I don't want a million classes. I like Tailwind, but I don't want million classes. I just wanted like this conceptually simple framework that most of the backend developers will be able to easily pick up, understand, use, and build applications. So in this case, I used Pico CSS and I said, you know what, from the npm.js website, when you open that, when you look for this, I have to show you this. So when you look for this package, Pico CSS, if you don't know what Pico CSS is, you can go and check. So it's really minimalistic CSS framework. It has everything that you will need, like in most of the cases, to do like basic apps, like their forms and things, that's the tables, switches, ranges, all sorts of like inputs and so on. I don't want to go into details. You can check. There are not that many components, but basically you can combine these components and create like really nice apps. You can also customize it and create like beautiful UIs if you really like. It's really up to you what you're gonna do. Anyway, and also you can have this like custom design systems. Someone developed this, so I'm just showing it's not our work, it's someone else's work, but you can change it. You can customize it and it's easy to understand what's happening behind. Anyway, so in order to use this thing, so you need to know first the name of this Pico CSS, how you find that. So most of the time when you go to their websites, get started, you say, hey, how installed? They usually say, hey, this is how you install this. npm install, then you have this name. So this name is actually what we are interested in. We don't want to use a CDN because I want this to work in offline. And so once you have say, hey, I want to use Pico CSS, then next thing is, all right, which file you want to compile? So what I said is, you know what? I would like to use the Pico, not the classes version, but the Pico, this one, Pico. So I want to use this version. So that's the version I want to use, Pico CSS. And that's exactly what I said here. So go to CSS and pick the Pico CSS file, bundle, compile that file, minify, do whatever you want, but that's what I need. Then I said, you know what? Every time something happens on the page, I would like to have some sort of like, progress. This progress is on top of the page and basically goes from left to right. That's all. So there is a really nice library. So these are like JavaScript, TypeScript libraries. And the idea is to be able to use like modern CSS libraries, utility libraries, or whatever. And also the like JavaScript, TypeScript, and so on. So if you check for this library, you'll be able to see that this is like very simple library. Maybe they have some demo. Let me check. Maybe there is demo. There's no demo, but anyway, again, we go to the npm.js, we look for the progress, and then we have to find now where this file is. So this file is actually here. So it's, but we need two files. We need the end-progress.js for the logic and for the style, end-progress CSS. So that's what we say. Hey, we want to use this library. We will need to compile this JSON file and this CSS, and if these files import other files, basically the bundler in the background looks for all of them, bundles them in one file, and that's it. So it's really similar how front-end developers work with the WebKit and Vite and so on. So Now, after we specify what kind of on the front end libraries we want to use like Pico CSS for the UI and nProgress for some UI like indication what that application is working on something. I'll skip this part for now. This is the client side that executes completely on the client side. Then we use our starter function to create instance of Gladius, the page, and page is like HTML without the body. So it's like everything that you specify, the title, the fav icon, the scripts, like, links, CSS, metadata, everything, create all of this for us and create app, because this starter is for AIO HTTP. So this is asynchronous HTTP web framework library. So I would like to have app created and returned with some things set up already for me there. And then we just specify what npm packages we want to be bundled. Every time you add them here, you'll see they automatically get recompiled, transpiled to a regular CSS and JS, which browsers understand, without user actually doing all of these parts. This is a single file application, like single page, single file application done completely in Python. And then after that, I create a page. So basically page, since we have the page here, I say, you know what, now create a body. I didn't want that bodies included because body can have some special properties, special attributes depending on the frameworks. So it was like really quick. Hey, you know what? G.body is like, writing the body tag. That's it. So it's like this. So basically everything up till here and this part, this is the page. And now we're creating the body tag. In Gladius, it's done with, so you don't have to. So basically, it opens the tag and closes this is called the context manager in Python. But there is one-on-one mapping between this code and HTML. So whoever is developing or working with the HTML should be familiar with this kind of technology. Tags are exactly one-on-one, exactly how they're called in like HTML. That's the name what is here. I didn't want to use any global names. Everything is, so this body is part of this instance of the Gladius called G. We can have many instances of Gladius and they should not be mixed, but that's the thing. Then we have this main. The main is a container class. So basically it's this one, what you see here on the screen. It has a class. We cannot just use class because class is a reserved keyword in Python. We say it's container, then we have one H tag saying, hey, Gladius demo, and then we have a single button. And this button has a label saying click me, and then it has also ID saying, you know what, my ID is that and that. So my ID is hello button. So here is the thing which I skipped. I said when you create the instance of Gladius with this starter function, you also, besides providing npm packages, you also have to provide either a function, Python function, which will be executed on the client side. So this function will be transferred to the client side and executed there. Or you can just write here in the string what other file should be imported and executed as it is. So that's it. It's simple like that. So it's either the function or the string that points to a file. So we can have other like client files next to app.py. So now the most interesting part will be to show you how to start this app and what happens. What happens here, it will be obvious. Basically, you will find this button. The more we type on the button, we'll have the indicator how many times we clicked on the button, and every time we'll have the progress bar. That's it. So we'll be able to use the Python variables, update them, and also use the JavaScript libraries without any issues. So we can literally import any library that we can think of. Okay, so let's see. We are going to this case. I'm going to source. I already have my environment. Expect that you know some Python because this is like it's not beginners tutorial how to use Python. We'll go to the example, let's say demo one, and then what I'll say is here is instruction in README how to run it, and so it can get automatically reloaded on change. So I can run it like this if I want. Let me very quickly remove all of the cache. I can run it like this. It's completely fine. Like, just 1 second. I was working on the new version, so something was changed. If I go to starter, oh yeah, this changed. So we don't have any more of this here. Okay. Started, so you'll see exactly what kind of npm packages it requires. It installs them locally, and very soon you'll see it says compile. Basically, now it compiles them, transpiles them, and that's it. So now we can open our application. It's on 5000 port. So I will open also the network tab, and I want to show you what is happening here. Refresh. So there is no, this is not like any HTMX like thing that where you click on something, it goes to the backend renders and returns everything. If you want to use HTMX, you can freely use it here, but this is not the case here in this example. So now if I start clicking, see, nothing happens in the network, like nothing gets sent, which means, hey, you know what? Actually, this code gets executed in the browser. So that's exactly what happens. So we say, hey, take this button that we created, this button by its ID. ID is hello button. Take it. Also set the variable clicked, how many times we clicked on the button to 0. Initially it's 0. And we said, you know what, this every time we click on this button, we would like that this callback is called. This event is also everything here is JavaScript object. So this event is actually JavaScript object, proxy to JavaScript object, but you can think of it as it is. We'll say, hey, the global is clicked. And then we use, for the first time, we imported the JavaScript library, in this case, end progress. And I said, you know what, start it. And that's exactly what it says here. If you go to documentation, it says start, call start, and done when you're done. That's it, nothing special. So every time you see that blue line going on top, really neat, really nice. Okay. So every time we click, we say, hey, progress start, increment the click by one, and then we change the inner text of buttons. So you see this inner text is actually, if you type npm Mozilla documentation, and you go to inner text, that's the properties. So inner text property of the HTML element, and button is a HTML element interface. Implementation of this interface represents the rendered text content of a node and its samples. So if we say inner text equals something else, it'll basically change its inner text, and that's exactly what we are doing here. Okay, so we're just saying how many times we clicked, and then once it's updated, we just say end progress done, so we stop the progress. So I just want to show you something really interesting here. So if I change, for example, if I don't want to stop this done, you'll see nothing happens here. And if I refresh the page, we just open, and I click, I didn't call done, and it didn't get recompiled. So in order to be recompiled, I need to call it one more time. Now refresh and say, see? Because there is no call to a done, this thing will look like there is some progress being made. How to run this thing so it automatically gets recompiled on change? It's very simple. In a README file, there is just one line based on Unicorn. There are all sorts of ways how you can do this thing, but this is one of the ways. So basically, use the Python, unbuffer, don't create cache files, use module called Unicorn, reload and change, bind on exactly the same address, 0005,000, timeout 300, number of workers 1. During the development, you want 1. Worker class, since this is IO, like asynchronous web framework, will need the appropriate worker class for the IO, and IO provides IO unicorn web worker, and then we just say which Python file. It's called app.py. We just type app, and also we need the name of the variable from that file, and this is the app that we want to run. So this won't be executed, because this app will be handled and all these parts will be handled by Unicorn from now on. And also just run it once and that's it. And now the magic happens. So I refresh, nothing changed. If I go to the code and just say, you know what, actually change this and progress, and we go quickly to terminal, you'll see it got reloaded. So it said worker reloaded. And now, yes, change is there. So you have that feeling, the same feeling what front-end developers have when they work. So they like to see these immediate changes. Another thing is, I also want to show you that part. Let's say that for some reason, I would like to change the style of the Pico CSS. So when you go to npm, you go to Pico CSS. Pico CSS. Go to code, CSS, and then you say, hey, I want everything to be blue. Maybe it's already blue. Let me check. Actually, it's already blue. We need some other color. So they compiled for multiple colors. Cyan. Okay, so let's do this. Cyan, or maybe they have. Oh, they have lime. Let's go with the lime. So if I type now Pico line.css and I click save, it will see that it doesn't, that it's something changed, the requirement changed, the npm packages changed, and it will reinstall them and rebundle them. But here is a really interesting and neat thing. First of all, let's see the effect. The effect is we got line. We're happy, okay? So when you open this demo, the only thing that you see here is your app.py application, which created static. You can create static if you want. It will check if there was the fav icon. If there is no fav icon, it will create the one. It'll just copy the Gladius, default icon. You can now go and change it. And for every npm package, it will compile all of its dependencies. So two dependencies are Pico CSS, this one. So we have the previous Pico CSS and now the new one, Lime. And then you also have end progress. End progress is compiled here. So it depends on CSS and JavaScript. That's why we have them. And we also have map, so we can debug if in the case of minification of these files. So how Gladius works and how it's able to do this. Gladius is based on two things. Actually on more things. I'll need to specify them differently. Number one is we have Python. And Python, CPython, that's what we have, or PyPy, that's something that what we have on the backend. That's what's running all of this. Like when you run the commands in the terminal, the API calls, all of this orchestration, how to compile stuff. That's like CPython or PyPy, or you can use both of them. Python 3.10 plus. Second, in order to have Python in browser, we use something called TypeScript behind the scenes, and you don't see that. But that's like very important thing. So we use the TypeScript. TypeScript is literally this. Oh, they're actually trying to run their demo, and I'll leave it so. They want to show you what they can do. So basically, you can run the Python from the browser. The implementation of Python, there is the full CPython for the browser, and it's multiple megabytes in size. We use MicroPython. MicroPython is mostly compatible with Python 3.10, and we try to keep like 3.10. Syntax is more than enough. Like for the most of the applications, it's really stable Python. When it comes to the features, and it's really feature rich. There are some things from newer versions of Python, but anyway. So MicroPython is like few hundred kilobytes of code, just like one JS file and one WASM, WebAssembly file. That's it. So that's how everything is implemented. So in background, in order to be able to run this code, we need TypeScript. And we need to tell TypeScript how to use these packages, npm packages here, so we can use them, and also how to execute code. And for that, we use the MicroPython. So we have CPython /PyPy / any modern like Python implementation, including Nuitka and similar. Then we have we have the TypeScript, which is responsible for handling interaction in the browser with the web APIs and also launching the MicroPython. And MicroPython is actually running the code that I just selected here. Then for this, we need the Node.js with npm. So Node.js and npm is required to install, and that's what installing means when you see it in terminal. We basically install all of this in temporary directory, so it's not visible here. You don't have node modules or anything. There is not such a thing. It will be basically npm installs everything in like temporary directory, and then after node/npm is done with installing, it's a fourth step. fourth step. We have the fifth step, which is actually building, bundling, transpiling, and we use the ESBuild for that. So ESBuild is a very fast, very configurable, very like, it's awesome. This is one of the best projects I ever worked with. So basically it knows how to transpile CSS, JavaScript, TypeScript, and that's exactly why we can use TypeScript, and it can look for all these dependencies and compile code to the final JavaScript code. You see, I mean, it's quite fast. The reason is I didn't pick ESBuild because it's fast. Yes, that's one of the reasons, but ESBuild, it's very easy to understand, very easy to extend. Their philosophy and the way how they explain stuff, it's very clear. It's like, so I made the same trade-off. So the trade-off here was we could use the CPython in the browser and have the multiple like megabyte file, but we choose MicroPython because MicroPython has most of the Python 3.10 like syntax and features. And it's great, and it's really fast, and it's really small. And then in case of the ESBuild, I know the limitations of ESBuild. It does not support the latest TypeScript, or it just like strips types. It maybe doesn't follow all of the rules of the TypeScript, but it produces the functional JavaScript code. And does a lot of this stuff like automatically for us in the background. And it's extendable through plugins. There are many plugins, so you can do many crazy stuff with it. Anyway, so that are the 5 key ingredients. Like Python interpreter that you have on a desktop, CPython, PyPy, Nutka, Grail, VM, and so on and so on. PyScript, MicroPython, Node.js/npm, and fifth, we have the ESBuild to actually bundle all of these individual packages that we just listed here. But the interesting thing is now, if I again change this, just this one line, I want to show you something. And these dependencies didn't change. So dependencies didn't change. And I click save. It reloaded instantly. Like this is like 0 waiting time. There is no, like you see, if you don't change npm packages, nothing happens. I will reload. There is no hot reload or stuff like that. It works great. But if I go here and say, hey, now I want to use red, and I want to also change that part. So I changed two things. So I changed the dependency, and I said I would like this. It will see that npm actually changed, and now it will fire the whole like bundling, transpiling process again and installing the process again. So this is the awesome part of the Gladius. And that's exactly how in just 50 lines of code, less than 50 lines of code, we were able to use. This is the client code, client-side code. Hey, and it's done in Python. Use Pico CSS for the styles. Hey, use the end progress for like indication of the progress on top of the page every time we click. Refresh. Now it's red. And then we have this part where basically we build the application, but we mostly care about this part here. So it's either this one here or this one here. So another thing is, so, okay, great. This is one single file, single page Python, completely 100% Python code that created a complete web application. So what about if we want to create a more modularized app? So that's why the same demo 0, it's re-implemented as demo 1. So in demo 1, it's even shorter. Again, we just have, we have the, I want to change this line to be as original, so we don't leave it like that. Okay, so now we again have libraries that we depend on. But difference here is instead of ready being function and that function being defined here, we can actually have the multiple modules and packages and separate our logic in them inside of them. So now we can have the client in the individual client app file. It can also use its own its own other like modules. So modules, the server side modules and client side modules, Python modules live in the same directory if you want, but they can be, you can separate them in different directories, like split them so you know what's in the quotes on the client side, what's on the backend side. But if you don't want to think about that, you don't need. You just throw them there and that's it. So now this, so we say app.py, please initialize and use the code when the application is ready and loaded from the file called client app.py. So that's this file. And this file has says import from my client utils import f0 function. F0 is here defined. So you see, like MicroPython has all of these sort of like these nice features like type annotations and so on. And then the code is actually moved here. So now everything has sense. Hey, here is the button. Great. Here is how many times it's clicked. This is the state. One line is declaration of state. And one line is just update of the state. And this is like really beautiful example. And then on the purpose, what we did, we just called F0 to print it out. So now why I'm showing you this, I want to show you, right, and explain how demo 1 works and how it's different than demo 0. Again, we're going to run it, so it basically sees all of the changes and reloads. And if I reload it, and we go to network, what we will see right now, we'll see the usual suspects, all of the npm packages that the code depends on, Pico CSS and progress, TypeScript. We'll see also MicroPython automatically included. We'll see our favorite fab icon. This is the fab icon of Gladius. And then we see MyPy. These are the stub. We call them stub libraries. And what they do is why they're called stub, because some stuff are missing from MicroPython. For example, some modules. You have the module called JSON. But you don't have module. Let me show you this. So if you say import JSON, it exists. Okay. But if you say import typing doesn't exist. So in order to use typing, you need these typing stubs or implementation of typing into your Python. So you can import from Python. So look where we find it. So you say micro Python typing. Sorry. So there is this thing called MicroPython stubs. So you go there, you go to MIP, and then you find the typing here. And there is also typing extensions, but you can use just typing, that's fine. So basically you find any container, text, generic iterators, async iterators, unions, tuples, all sorts of like these typing things that you usually import in regular Python. Anyway, all of this is done for you, so you don't have to take care of this. So there is typing for you. And then there is your app. So what it figured out from your source code, hey, this is the server side code. This will never be transferred to the client side. So you're safe, whatever, even if you make a mistake and type like secret code here. But whatever file you passed to be included, like run when it's ready. So we are going to open that file and traverse from here every import through the file and look for all of these files. And basically, since we looked for client app.py, and this is this file, and that file looked for the client util.py, both of these files will be included and sent over the network to the browser. So you can actually see them here. So here they are. The app is here, exactly what we wrote. There is no transpiling, nothing. It is as it is, like the plain JavaScript. And also the same thing applies for the client util spy. When you use TypeScript, in order to achieve this, no matter how great this thing is, and that we built everything on top of this, you have to configure manually and say exactly every Python package that you want to use, interpreter, versions, if it's MicroPython, what kind of files. So all of these files, you have to write them manually. These are the files that you will transfer, and you want them to be able to you want to be able to import them as they are in your local directory, which means you have to write all of this stuff by the hand. And that's very problematic. That's number one. Number two is, if you want to use the JavaScript libraries, then you have to specify absolutely every JavaScript, first bundle or use the CDN. But if you use the CDN, you might not be able to use this in offline mode. And also specify by which name it will be available inside of your TypeScript application. So nevertheless, this is available. We decided to actually take care of this automatically for you. So you can check. So let's first prove that this thing works. It works. Great. Awesome. You see, this is instant. There is no delay, nothing. So basically, of course, it's working a little bit slower than JavaScript, but in this, Python they call it glue programming language. It basically glues C, C++, Rust, Zeek, all of these libraries written in the lower languages, or Cython, which is flavor of Python, and it allows you high level implementation of the features of application logic by using this low level libraries. And that's how C Python actually works. Most of these crucial performance libraries are written in C, and then they have nice Python wrappers. So to you as end user and programmer, everything looks like it's written in Python. So here, the goal is to make to use Python is actually used as a glue language to JavaScript, WASM, to CSS, web APIs in the browser. So you really don't pay huge price, because all of these APIs, once you pass data to them, they take care of the rest, and they do the magic. So let's see how is this actually why this works. So if you open what we initially transferred, you will see exactly that we built, as I said, we built the page. Body's here. Body's ours. Body part, that's ours. And these files, so we built that for you. So Gladius built that. It recognized, it reversed, so it found missing modules that you have in packages that you have from the standard library. In this case, we only care about typing. And it found all of yours that your code uses on the client side by traversing abstract syntax tree and looking for the dependencies and building this dependency tree carefully. Then it checks for your npm.js and includes only what you need, and all of this is actually bundled. So we get really nice experience as developers. So yes, if you want to develop your code to be in a single file, you can have a single file, single page application. But if you want to have your logic separated, separation by concern, you can have that as well. So you can have all sorts of different abstractions. So now you realize, so Gladius is library that creates, it is like the template engine, but it's not just template engine. It is high level template language here, number one. Number two is, so it also has this bundling and configuration, auto configuration stuff and everything that you require. And it puts everything together for me so I don't have to care about these things. So there is no config file written anywhere. Your code is your configuration. That's the beauty. That was the goal. The goal was so client users don't go somewhere else and read that there is config files which they have to write manually, include like in case of the TypeScript, and do all of these sorts of stuff. Anyway, now this was really simple example. I'll jump to the next example, and this one is a little bit more complicated. So what this one does, it uses Alpine JS library. So Alpine, I choose Alpine because I wanted some reactivity in application on the client side. Because in order to build nowadays like modern applications, you need, whoever developed this page needs to have a dark mode. And my dark mode sucks. All right, so Alpine. So Alpine basically has only 15 attributes, and it's self-explanatory. 15 attributes, how it works, how you define your data, how you bind values, like how it listens to changes, stuff like that. It's not like React, it's not like Solid, it's not like Svelte. It's a very simple thing. There is no bundling, there is no bundler, there is no configuration. It's just one file, Alpine, and I'll show you that there are 6 properties and there are 2 methods. So we use mostly this method to define the like global store, the global state. And if this state changes or if dependencies change, it will trigger the re-render of the parts of the page on the client side without interacting with the server. So this is, I mean, I could use as example, probably I will use HTMX, but I wanted to show, hey, what is the simple library like HTMX, but that's completely client side, so I don't have to deal with the reactivity, and I can use it from the Python. This is the beauty. I want to use this from the Python and write code in Python that use this library. So in this case, we said, all right, again, use the Pico CSS, use the Alpine, use the Pinecone router. I didn't use it in this example. Example is still very simple. Future might be a little bit extended. So the reason why I have this Pinecone router, this is the router for Alpine. So on the client side, we can have routing, like we have like React DOM routers and like Svelte routers and so on and so on. So we can handle the navigation on the client side only, and we don't have to ask the server to re-render the page or send you the new content for the new page and so on. So that's the reason why it's there. And we still have the end progress just because we want to. This case again, I decided that I will not include any client code here, except like just defining the page. I said, you know, the logic is in client app.py. The whole logic is here. We'll go over it very, very quickly. So let's see what's in the page. In the page, we have the body. We have to state, hey, here is X data, because that's required in order that the application is considered, from that moment of time, it's considered Alpine JS. Again, I'm not the front-end developer, but I need to develop the both backend and front-end application to build these solutions really quickly. And I don't have days, weeks, months of waiting, sprints. I want this immediately as I think. And this is really good for developers who are full stack, who understand the full stack. We're mostly backend developers and who need solutions really quickly. So, we say X data equals done. So basically this triggers and said everything from this point is actually reactive. It uses the Alpine. And then we say, all right, again, the main has it has a class container. We have the header. And then in that header, what we have a simple form with just one input where we input the message and one submit button where we send the message. And the goal is when you enter that message you press enter in the input, or you click on a button, send message get added below that input, like in the list, and that list grows, but the whole thing grows on the client side. Before I show you the code for what happens on the client side, let's go to that example and let's see how it works. Again, let's refresh. So this is the example now. So if I type hello and I press enter, it'll enter below. Or if I type hi and I click send, again, it will go below. Easy like that. So how this thing works, I haven't done that yet, like that part yet. So basically, you have the client app. We import Alpine.js. We import the Alpine router. We don't use it, but we import it anyway. This is required. Why? Because you basically follow the JavaScript documentation when you do this stuff. And I'll show you, like, this is a really interesting part. So if you go to the Alpine and you go to their documentation, docs, and they say if you want to use install and you want to use npm install, you have to import Alpine like this. And you have to say window.alpine equals Alpine and then Alpine start. So that's exactly what we did. We imported the Alpine. We said window.alpine equal Alpine, and at the end we have Alpine start. Everything in between is everything in between. So now here is like one utility function which will end up being automatically included in very quickly in all of the Gladius future Gladius versions. Anyway, so now we have Alpine init. So Alpine init register, and I said listen event when Alpine init is when initialization happens, and call that function. So this function will be called only when Alpine is initialized. So what I say then, hey, you know what? I would like to create the store, the global store. And this is exactly documentation from the Alpine. So if you go to Alpine and you go to their store, so you'll find it here. Maybe this is too simple example, but maybe here. Yeah, it's here. So instead of notifications, here in our case, it's called messages, and items are actually the messages. And then you have what function should be called when we add the message. You can write as many functions as you want, and you can call them for adding, removing. Right now we just have for adding. So we say, hey, items is actually the empty array. We have to use 2JS. This is the function from the TypeScript. Every time you want to transfer the object from the Python to the JavaScript, you do that by creating the proxy object, and that proxy object is created using the 2JS function. So what's the proxy object? It basically proxies all the function calls, all of the attribute lookups to the real Python object. So the Python object looks like it's actually JavaScript object. In this case, messages should be just one object, and items should be just array. Here we had to convert that to wrap it with 2JS. So just if you remember, every time you have some reference type object such as dict or list or tuple, you just do 2JS and that's it, problem solved. So items is empty array, And notify is actually this notify message function defined above. So this message is called every time someone from outside calls this function. Who calls that function? That's the event that gets called when you click on this or you type something and press enter. So what this function does, it says, hey, give me items for the store, global store core messages. Give me items. And these items, this is a list. But not really a list. It's actually JavaScript array. And I'll write it like this. So you can have annotations and strings in Python completely fine. They're ignored. They're also, they're mostly used for the forward reference types, but you can use them so you know what's the inputs. So basically inputs is a real JavaScript object. And then you say, hey, inputs dot push. This is because JavaScript array has the push method. And you say, hey, add this message. So you see that the front-end developers that know JavaScript and the back-end developers that understand this, how JavaScript works, they know that they can use Python syntax, Python calls, Python semantics, everything, but I just use the API, web API. In this case, we use the array API to push the message inside of that array. And that's this array. Initially, it's empty. So when it gets called when we have one. So here we defined one event on the key down. This is the Alpine event. And we said call send function. Same thing. Every time you click send, we said, hey, every time you click send, called also send function. That send function is this function here. There is decorator export, and why we require that decorator export? Decorator export is required so we can, so we don't have to write window.send equals send. That's the reason why. So, and that export is actually implemented here, and that's why I'm saying it'll be included, so you don't have to worry about this part. You don't have to copy paste every time this function. So you just decorate your function that you want to be globally available. In this case here, globally available so you can use it. So since the same callback function is used for the key down and for the submit button from here. So every time key down or submit on the button, what we do actually, we check. Hey, check if event is click. The click event is obviously for the send. Or it's key down and it's enter. That's when you're here. If it's not, none of these two, return, just exit. Otherwise, continue. And then we check if there is event, and event has the prevent default, called event prevent default. And front-end developers know why this is called, to stop the propagation of the event processing through a chain. And then we say, hey, I mean, this is our simplification, but that's what happens. So then we say, hey, now I need from this store, besides having items, which is just array, it has a function called notify. I need that function. So Alpine, we say Alpine store, give me the Alpine store messages. And from these messages, give me the notify function. Give me that function. And then once you get that function, you can call it. So what we do, we say, hey, find what's in the message input, what's typed here, find it. And then take the value from that element and pass to the notify function. So this notify function is this notify function here, and it'll basically add the message to the list of the messages. Then what we do, we clear this input. So it's always, and we refocus. So we clear the input and we refocus. That's why we have these two lines here. So when this notify is actually called, what happens? Yes, the new message, which is simple string, is added to the list of items. It's pushed there, and it immediately fires everywhere that code dependent on that store, in this case message, to re-render. And where is that code? So how is this part re-rendered? It's again very simple. That's why I actually chose the Alpine.js. So here it is. Here is the G template. X4, this is Alpine way of doing things. You say for m in store, store meaning global store, messages, items. So that's this. Messages, items, go through it, iterate with m in. In JavaScript, this is usually called for m of and then the name. Anyway, but this is JavaScript anyway. So because it's Alpine, and then we iterate over that, and then we just create the p tags with the text, whatever was in the m. And because m was the string, it will just create this thing here. So if I go to the main, we'll see the form here, and just below the form are the p's. But another really interesting thing is, when you add something, you will not see all of this re-render. You will just see one thing. It'll flash at the end, and there'll be just a single change to the DOM tree. And it's very fast. That's why Alpine is chosen. So I explained it. Pico CSS, very simple for the like everyday Python developer, backend developer, number one. Number two, Alpine, because on the client side I wanted something simple. There will be the demo coming, and I actually might write example how to use like routing on the client side. And then the next thing with the Pico CSS is, people usually ask me like, because why I give them advice to use Pico CSS instead of going with the Tailwind and like for example Daisy UI or Tailwind UI. This library is on top of the Tailwind CSS. Since it's very small, very clean, very simple, it's very easy to extend. And now you can create the apps where you can have the footer, the sidebar, and the header and the navbar in the header. And you have also, so you can have some sidebar, left, right, comment. I mean, you can have on both sides. On left, you have the links, how to navigate through the app, or like showing the files. On the right, showing maybe the properties, whatever. In the middle, having all of this chat. This is like chat-like on purpose, because one of the future examples will be about like how AI, to integrate AI here and have everything into the single process. I mean, when I say AI, I mean LLM engines or VLMs or something like that. We'll see. And also on the bottom, you'll have the traditional footer. So always header on the top, always footer on the bottom, maybe the left sidebar, maybe the right sidebar, and this the main thing of the content in the center. But that's something that will come into next videos. For now, this is it. The goal was to show finally. The goal was to explain to everyone and show everyone, hey, you can finally develop the full stack apps completely in Python. For the Python side, since it's agnostic, hey, take every Python library you like to use it the way you want to use it. On the client side, you have all web APIs already baked into the browser, and plus you have all of the npm.js like ecosystem packages. So use them. There is that's it. Like it's simple like that. So I did not want to send, for example, numpy array to the client and then have a client handle the numpy. Yes, Pionite. There is the let's see Python like Python version that works in the browser. I didn't want like multi-megabyte environment and also slow. and I didn't want to have all this like heavy Python libraries on the client. You can have them, but that's not how this is built. I wanted to allow people on the client side to use the web APIs, native web APIs with the Python. That's it. And just read the JavaScript/web API documentation, check the npm.js ecosystem, which is huge. Take advantage of it and think how to use it on the client side. On the server side, use everything that's in the Python index, IP. So that's it. I would like to end video here. This is stream. I will definitely cut portions of the video to create the smaller ones with the more direct explanations and direct to the point, descriptions like why code is implemented as it is and why it works. As I said, I'll probably keep doing these videos more frequently now, and this opens the door. So now, once we removed this the huge impedance between the backend and front-end development, and you know now that you can have something in matter of days instead of weeks and months, which is usually a case, and I don't want to go into details because it's, again, as I said, controversial topic. I want to show you, because the library is very simple, how even without the proper documentation and the insight and being fine-tuned and trained, LLM's models can understand the Gladius code and use the Gladius few examples, and then answer to your questions. For example, you'll give example of Gladius like hello world, and it'll immediately figure out the small LLMs will figure out how it works, and basically they'll spit out that code that you can immediately use and have it working. And if you remember from the beginning of stream, the goal in 2008 was to explain in natural language, in simple English, let's say, or Chinese or German, Italian, Spanish, all these beautiful languages. You say what you want and you get your code written on the fly, doing exactly what you look for. And also to show you that you can host all of this without expensive hardware, probably serverless, running locally in your machines, not requiring like expensive GPUs. There are plenty of technologies to be covered. Stay tuned, and I hope you're gonna have a lot of fun in the long run this time, because this is my stream after 2 years, like without streaming about anything meaningful. Thank you so much. See you soon. Bye.